Hello everyone. In this video, we'll discuss about Bohr's atomic model. Before discussing about Bohr's atomic model, we'll discuss about failures of Rutherford model. Rutherford model failed to explain distribution of electrons outside the nucleus. So though he gave one statement like this, electrons revolve around the nucleus in circular paths. So according to classical theory, if any charged particle is moving in circular path, it must lose its energy continuously and has to fall. So it has to come to rest so that it slowly that electron's velocity must decrease and they has to fall inside the nucleus, but it was not happening. And the second thing is, according to classical theory, whenever an object is continuously losing its energy, whatever energy is released, if it is observed in the form of radiation, according to Rutherford model, it must be a continuous spectrum, but actual hydrogen spectrum is a characteristic spectrum, so failed to explain hydrogen spectrum, which is characteristic in nature. But according to his classical theory explanation, if electron is losing continuously energy, we must observe continuous spectrum. So these two are big failures of Rutherford model. Then Bohr proposed his atomic model like this. In neat point of view, it is very important. Bohr's atomic model. So actually, this was explained for only one electron system, or we can call that as hydrogen-like. So according to his theory, we are having some postulates like this. The first postulate will be like this. Electrons will revolve around the nucleus in various paths called orbits. So in only those orbits whose angular momentum is integral multiple of h by 2 pi. So that is our first point. Electrons can revolve in only those orbits whose angular momentum is integral multiple of h by 2 pi, or we can write like this: mvr is equal to nh by 2 pi, where h is Planck's constant. So and v is velocity of the electron. If suppose this is our nucleus and an electron is revolving in an orbit of radius r with velocity v and its mass is m, and mvr will be equal to nh by 2 pi. Here n takes values from 1, 2, 3, 4 and so on, where n is known as principal quantum number. Principal quantum number. And after this, the second postulate is like this. As it is moving in a circular path, definitely it will have some centripetal force. Who is providing the centripetal force means Coulomb force between electron and the nucleus will provide necessary centripetal force. Coulomb force between nucleus and electron provide necessary centripetal force. So that if suppose nucleus charge as it is Ze and electron charge is E, so that Coulomb force is K Z E square by R square, and that must balance with M V square by R. Here K is Coulomb constant, whose value is 1 by 4 pi epsilon naught, which is a 9 into 10 to the power of 9 Newton meter square per Coulomb square. So that is our second postulate. And as long as electrons revolve in their orbit, they neither gain energy nor loses energy. If the electron is making a transition from one energy state to another energy state, or one level to another level, so they lose or gain some energy that will be absorbed in the form of radiation. If an electron makes transition from higher orbits to lower orbits, energy is observed in the, or energy is released in the form of radiation. So that E2, if suppose higher state energy is E2 and lower state energy is E1. So as long as they are in one orbit, they will not radiate any energy. That's why we'll call them as non-radiating orbits. But if an electron makes from one orbit to another orbit, definitely it will lose or gain some energy. If it is coming from higher orbit to lower orbit, definitely it loses energy in the form of radiation. Here nu is the frequency of radiation. And of course H is Planck's constant. Now, once we know these three postulates, we'll have certain parameters which we can expect as some questions based on this in our NEET as well as JEE. The first parameter is radius of the orbit. For this, from our postulate 1, as we are having mvr is equal to nh by 2 pi, we will take, or we will rearrange this equation for V. V is nh by 2 pi mr. We will substitute this in postulate 2. Our postulate 2 is mv square by r is equal to k z e square by r square. So r gets cancelled. M into v square, which is n square h square by 4 pi square m square r square is equal to k z e square by r. So r gets cancelled. So now from this we can m gets cancelled. We can rearrange for r. R will be equal to n square h square by 4 pi square m z e square. So this is our general expression, and we'll have k also, this Coulomb constant. So in this, the variables are n as well as z. So radius is directly proportional to square of the principal quantum number, and radius is inversely proportional to z, and radius is inversely proportional to mass also. You have to remember this. And if I substitute that for hydrogen, Like or for electron, as we know, mass of electron is 9.11 into 10 to the power of minus 31 and charge of the electron is 1.6 into 10 to the power of minus 19 coulombs. And if I substitute all other constants with Planck's constant value as 6.626 into 10 to the power of minus 34 joule per second. If I substitute all these values, I'll get this as R is equal to R naught into N square by Z. We'll write like this. This R naught value is 0.529 angstroms. That is also important, and you'll have some good number of numericals based on this. R1 by R2, that will be equal to N1 by N2 whole square into Z2 by Z1. So you can expect some comparison based questions on this. And after radius, that next important parameter is velocity. As we are having our radius equation like this, from our postulate 1, as velocity is nh by 2 pi m into 1 by r. We'll substitute this r value from our first equation over here. That will be nh by 2 pi m into 1 by r means it will be k into 4 pi square m z e square by n square h square. So from this nh gets cancelled and mass gets cancelled, and we can observe like this: velocity depends on z and n. So from this equation, this 2 gets cancelled, pi gets cancelled. So we'll have velocity is equal to k into 2 pi z e square by n into h. So from this equation, let this be our second equation. We can say like this: velocity is directly proportional to z, velocity is inversely proportional to principal quantum number, and velocity is independent of mass. So from this, v is equal to, if I substitute all those constants, we'll get 2.18 into 10 to the power of 6 into z by n, or else we'll represent this as v naught into z by n. This is velocity equation. And this V naught value, that is 2.18 into 10 to the power of 6 meter per second, is approximately equal to c by 137, where c is velocity of light. Okay, that is about velocity. Once we know velocity and radius, the next parameter they'll ask you about angular velocity. Here onwards, that proportionality constants are important. For angular velocity, if I'll represent with omega, as we know that relation between angular velocity and linear velocity is v is equal to r omega. And one more thing, we know that here velocity is proportional to z by n and radius is proportional to n square by z. So if I'll use this as omega is equal to v by r, so omega will be proportional to z by n by n square by z. So omega is proportional to z square by n cube. So you can expect some questions based on this, that is about angular velocity. Once you know angular velocity, they may ask you about time period. So time taken to complete one revolution around the nucleus, we'll call that as time period. How it depends on omega means t is equal to 2 pi by omega. So that time period is proportional to n cube by z square. And once we know time period, they'll ask you about frequency. Frequency which is reciprocal of time period. So that this will also be z square by n cube. Frequency also proportional to z square by n cube. And after this, they may ask you some questions based on that acceleration. So what kind of acceleration it will have means centripetal acceleration. Centripetal acceleration is v square by r. So that v square means as v proportional to z by n, so that z square by n square by z. So acceleration is proportional to z cube by n power of 4. That is about acceleration. Once we know acceleration, they may ask you about, as we already know current and time, they may ask you about frequency. And once we know frequency, they will ask you about current. As electron is moving in a circular path, that current can define as charge by time, or that is charge into frequency. So as frequency is directly proportional to z square by n cube, so current is also proportional to z square by n cube. And after this, as some current is produced, so I can assume this as a current carrying loop. They will ask you about magnetic field produced at the center of the loop. Magnetic field due to a current carrying loop, it is given as mu naught I by 2r. So B is proportional to I by r, or that is equal to I is proportional to z square by n cube, and r is proportional to n square by z. So B is proportional to z cube by n power of 5. And after magnetic field, they may ask you about de Broglie wavelength. So as we are having mvr is equal to nh by 2 pi, I can write the same equation as 2 pi r is equal to n into h by mv, or this h by mv we'll call that as de Broglie wavelength. So 2 pi r is equal to n lambda. We can write that first postulate even in de Broglie wavelengths like this. So now lambda is proportional to r by n. So lambda is proportional to r is nothing but n square by z by n. So n gets cancelled. So lambda is proportional to n by z. And after de Broglie wavelength, they'll ask you about magnetic moment. Magnetic moment, as current carrying loop is there, that magnetic moment, if radius vector is r and current is I, as the electron is moving the velocity v, so that magnetic moment is given as current into area, that will be equal to current into pi r square, and as r is n square by z, and current will be equal to z square by n cube. Current is proportional to z square by n cube. So magnetic moment is proportional to z square by n cube into n power of 4 by z square. So z square gets cancelled. Magnetic moment is proportional to n only. So we can give one statement like this: independent of z. Independent of z, that is atomic number. That is about magnetic moment. Once we know about magnetic moment, here itself we can speak about angular momentum. As angular momentum is m into v into r. M into v is proportional to z by n. and r is proportional to n square by z. So angular momentum is also just depending on principal quantum number. It is independent of z. So among all the parameters, only two parameters are independent of z. One is magnetic moment and the other one is angular momentum. And the last parameter is energy. We are having a nucleus like this whose charge is Ze. An electron is revolving around the nucleus in a circular orbit. They are separated by a distance r. Electron is negatively charged one. So that potential energy will be like this. Potential energy. That potential energy will represent with U. That is minus k z e square by r. And kinetic energy, if I will represent with ke, this we can find from our second postulate, as we are having k z e square by r square is equal to m v square by r gets cancelled. So we are having m v square is equal to k z e square by r. So once we know this, kinetic energy is half m v square. So that will be half k z e square by r. That is about kinetic energy. And once we know potential energy and kinetic energy, we can find total energy. Total energy, if I'll represent with E, that is sum of potential energy and kinetic energy, that is equal to minus kz E square by R plus kz E square by 2R, or this will be equal to minus kz E square by 2R. So from this, we can come to one conclusion like this. Magnitude wise, total energy and kinetic energy are same and they are half that of the potential energy, of course. But for total energy and potential energy, we are having same sign, whereas kinetic energy is positive in nature. And if we draw a graph between energy and distance, all energies will give you rectangular hyperbolas. They are inversely proportional to distance. But as it is positive, this is kinetic energy, and potential energy is more negative, and total energy is less negative. So more negative will be potential energy and less negative will be total energy. You can expect some questions based on this. Now from this equation, as energy is minus kz square by r, we are having r is equal to r naught into n square by z. If I substitute that over here, this will be equal to minus k z e square by 2 into r naught into n square by z, or this will be equal to minus k e square by 2 r naught into z square by n square. This entire value, if I can calculate by substituting all those values, we'll get that as minus 13.6 electron volts into z square by n square. So that is energy of an electron in nth orbit with atomic number z. For hydrogen, z is equal to 1, so that energy will be equal to minus 13.6 electron volts by n square. If n is equal to 1, we'll call that as ground state or first quantum state. So if I substitute that n is equal to 1 value, energy of the first state will be minus 13.6 electron volts. And if n is equal to 2, that is first excited state or second quantum state. We'll substitute that E2 will be equal to minus 3.4 electron volts. N is equal to 3, that is second excited state or third quantum state. Then that value is minus 1.51 electron volts. And if N is equal to 4, that is third excited state or fourth quantum state, its value will be minus 0.85 electron volts. And if N is equal to 5, it is fourth excited state or fifth quantum state, and its value will be minus 0.54 electron volts. So at least we have to remember these 5 levels values for our numerical purpose or for any quick solving for questions. These 5 states energies will be helpful. That is about parameters, and I'll close this video with one simple example. If suppose you are given like this, if Coulomb force is inversely proportional to fourth power of radius, then and that atom is obeying our Bohr's model. As it is obeying our Bohr's model, definitely we are having this MVR is equal to NH by 2 pi. Then they'll ask you find relation between R and N, radius and principal quantum number. So according to this question, Coulomb force is given as kZe square by R power of 4. This must be equal to mv square by R. But as we are having V is equal to NH by 2 pi mR, from this equation I can write kZe square by R power of 4 is equal to m by R into n square h square by 4 pi square m square R square. So that this R square, that R cube, R power of 4 gets cancelled. And of course mass gets cancelled, but they are asking only for relation between radius and principal quantum number. So R is inversely proportional to n square. You can expect some questions like this also. By changing that Coulomb force, they may ask you what is expression for radius, like that. So that's it for this video. I hope you all enjoyed this video. For more videos, please subscribe and share Progressive Physics Learning, which is helpful for both JEE as well as NEET. Have a great time.